Hi, I'm Dr. Sonia Brown, Senior Lecturer in Aerospace Design at the University of New South Wales. In aircraft design, we have to balance a number of factors. For example, aerodynamics, propulsion, structures, flight stability and control. So we've got a number of things to balance. And the reason that aircraft, particularly commercial aircraft, have evolved the way they have is because of a balance of a lot of those factors. For example, we have a cylindrical fuselage that is relatively good aerodynamically, but also it makes the pressure distribution, when we're talking about differential pressures when we're flying at 30 to 40,000 feet, even around the fuselage, which is really good for our structures. The blended wing body design is really efficient aerodynamically because we get rid of the joins between the wing and the fuselage, which is great for our fuel efficiency. So that's a real positive about it and viable in that sense. It does have some challenges, particularly in terms of passenger acceptance. There's a lot less window seats, and if you're seated somewhere in the middle, you're a long way from being able to see out the window. That also impacts emergency exits. Those people in the middle have to be able to get out, so you need more seating spacing to get more emergency exits out to the side. We don't have that nice cylindrical fuselage for pressure distribution, so the structures will have to be designed to be stronger than, say, a typical aircraft. The fuel placement needs to be looked at carefully because the typical wing area is smaller, and also on this, the engines are at the back. So where that fuel is stored, making sure there's proper separation from the passengers and then the fuel transfer through to the engines at the back. Taking a look at the Flying V now, you can see it's a very non-traditional aircraft. The first thing again is the structure. It's a very interesting shape, far from cylindrical, which is going to mean the structural weight is really high. The passengers are in these two V areas. Now, a boarding gate at an airport is always from one side. So it's like those emergency exits have to be on the leading edge of the wing. It's almost like you're going to have to climb out. Not ideal for emergency exits for our passengers. Another big concern is fuel storage. Where is it stored in this design, and how does that separate from the passengers? This TriWing design that we see is, in my opinion, not very viable. Each of these wings, as shown, is really thin. This is going to impact the wing bending, which means as we fly, it's going to be lifting up quite significantly unless the structure inside there is really quite heavy. Each wing is going to affect the wings behind that aerodynamically. So wing wakes, our high angles of attack, as well as the vortices coming off of the wing tips reduce the lift on the wings behind it. Additionally, in terms of the engines on this design, there is two engines, but they're stacked on top of each other at the back of the aircraft. If one engine was going to catch on fire, that's going to progress pretty quickly into the second engine, taking out all our engines. This double bubble design is almost like a cross between our blended wing body and our traditional cylindrical fuselage. Basically, we've got more flat surfaces compared to our traditional fuselage, which means we've gone away from our cylinder and our benefits of pressure improving our structure. The designers have stated there's aerodynamic benefits in that they've made that fuselage somewhat like a lifting body, which you would expect in the blended wing body. With how it still comes down at the side, you'd expect some more turbulence there because the lifting body means we've got the higher pressure below and the lower pressure above. The other concern with this design is the closeness of the engines at the rear of the fuselage. That's going to impact our redundancy. If something happens with one of the engines, it could quickly move to the other engine, making it less safe. So looking at the truss-based wing now, trusses are used on a lot of really small aircraft that go a lot slower. The reason they're not used on our commercial aircraft is actually typically because of drag. So in these truss-based wing structures, what we're looking at is how to design the truss itself to be more aerodynamically, because if you make that more like an aerofoil itself, it can actually support and add lift and not have the drag implications at the higher speed flight. What the main purpose of this truss is to actually reduce those wing bending loads. Lift creates this bending load. The truss helps reduce the structural requirements, so it reduces the structural weight, which is really beneficial. As long as you can reduce the drag from that truss, it's pretty viable overall. The Stark AVL isn't that different to our current commercial aircraft. All they've added is this hydroelectric engine at the tail. So it's drawing in boundary air layer, which adds aerodynamic efficiency. but it's also electric powered. It is powered by the main two engines, so it's adding some extra propulsion using green energy. Because it is a whole new, very different propulsion source, it would be extremely costly to actually certify this design. From, I guess, a business perspective, I would see it as less likely to be implemented in the future. The box wing design is actually really aerodynamically efficient. It's got the low wing at the front and the high wing at the back. That actually avoids any of the wing wake that we've talked about previously. They're also connected at the wing tips, which is better than a traditional winglet that you might see on commercial aircraft because it stops the air circulation, improving our drag performance and improving our fuel efficiency. Challenges with this design is actually how it's going to interact at our airports. Due to the wing structure, it seems like it'll be really challenging to get a rear boarding in there, but also because of how the wing structure is, you wouldn't be able to, say, add a mid-door boarding very easily or at all, so it would be reduced to probably boarding at the front of the aircraft only. The bird of prey is really a concept set to inspire, to encourage people to think outside the box. So we do have a lot of good things in our current designs, but to look to the future and get the most, we do need to be thinking about development. For example, it encourages us to think about birds, who are obviously really efficient in flying and have been flying for tens of thousands of years. Some good concepts that can come out of that is control surfaces that are integrated. For example, they become part of the wing. Effectively, rather than being a separate surface that deflects, they'll be integrated, so maybe the wing will bend at the trailing edge to give that same control, and that's more bird-like. So it tells us that potentially we can optimize some of our aerodynamics further to get to a bird shape, and potentially that could be advantageous to us. So it's more about getting people to think and challenging some of the assumptions. So there is good reasons we do things as we are, but you don't ever get development unless sometimes you think outside the box.